My name is Morteza Biglari-Abhari. I'm from the Department of Electrical and Computer Engineering. The purpose of this presentation is to give you a short introduction to our computer system engineering program. So first, we look at the challenges that are faced by computer engineers in 2020s and behind. We look at them from application point of view. One of the most important and becoming even more important than before is the application in the area of artificial intelligence and machine learning. The other important application is the rising of autonomous vehicle. So we see more details of this later. Intelligent medical devices are going to be spread all over. And robotics, they've been around for some time. They're becoming more sophisticated and more intelligent. And also augmented virtual reality, which currently are used in video games or special effects in movies. They also becoming an important part of all of other applications to provide more information to the users. And all of these, when they are implemented in their specific intelligent devices, they are connected together through internet to make the so-called Internet of Things. So this enables us to design smart cities when we use different type of intelligent computing devices for different applications. For example, in smart factories for industrial automation systems, we use for transportation systems, autonomous car, connected traffic cameras, all they communicate together through internet by using the cloud. Going towards other applications like intelligent hospitals, and as well as a smart city, a smart stadium, and so on. So all of these technologies will be used in different type of applications that we see they are emerging in the next decade and so on. Okay, we talked about we talked about Internet of Things. Now we see what we mean from that by just looking at this short video.
It's a world that's constantly changing all around us due to these sensors and the internet, and we call it the Internet of Things. Let's stroll into the living room of the future. Now, immediately, this room identifies you and taps into a cloud-based profile of preferences like climate control, music, lighting, and decor. Had a long day at work? The room knows, based on the calendar app on your phone and biosensors that detect the stress via blood pressure and heart rate. So it turns off the rockabilly surf guitar you usually listen to and switches to a more soothing classical music. From environmental sensors outside and maybe even worn within your clothing itself, it knows it was snowing earlier, so the climate control begins to crank up the heat in anticipation as you walk through the door. Now, on the software side, we're talking about algorithms that are so sophisticated, they may be able to predict what you want before you know you even wanted it. So when you walk to the refrigerator, it tells you not only what's in there, it tells you what you can make with the stuff you already have. And it's already telling you what's inside and what's the perfect meal based upon your mood, your activity level, and maybe even, well, your weight loss plan for some of us. So we're going to live in a world completely filled with sensors, with data, reacting to us, changing every moment dependent upon our needs. I'm no longer going to be asking you, hey, what's your favorite color? What's your favorite music? I'm going to ask you, what's your reality like?
Okay. And this year, the demos that you see, which are organized by Faculty of Engineering, they target different teams. So these are the list of those different things. Those highlighted in red are them that are more relevant to computer system engineers, and we see examples of some of them in following slide. For example, for food, a smart packaging system can be used to preserve food longer. All of these need intelligent computing devices which should be designed by computer engineers. Or from health point of view, we have lots of medical devices. Some of them are implanted inside the human body using wireless communication system to communicate to a specific server or the places that medical doctors can collect information. These devices, some of them, as I said, are placed inside human bodies. Some of them are outside human body but closely attached to human body, for example, pacemaker, insulin pump, etc. In addition to these, there are also sophisticated medical equipment which are used by medical doctors and healthcare workers to facilitate and assist better diagnosis and treatment. So this is again one example of target application which computer system engineers are involved in designing these devices. Then looking at robots, robots have been used for industrial automation, which resulted in higher quality product, lower cost, shorter time to market. So we see more on this, especially by employing the techniques from artificial intelligence to even improve the quality of the products. But using robots in industry doesn't mean that humans will lose their job, because robots are here to assist humans, not to be a replacement for human workers. The other area which robots have been used is space exploration. As you know, NASA used Mars rover, for example, Esprit or Opportunity. So again, in these robots, there are lots of things that has been designed by computer engineers, from all sophisticated hardware component and software component. The other challenging criteria that should be considered here is, because space is very hostile environment, cosmic rays create problem, so the system reliability need to be improved, hard real-time deadline also should be met. So those are additional factors that should be considered when designing such robots, and again, that's the job of computer system engineers. Okay, we talked about artificial intelligence. This short video gives a quick overview of what it is.
Artificial intelligence is really techniques that help machines and computers mimic human behavior. It's like a Russian nesting doll. Artificial intelligence at the highest level is the device being smart. How it becomes smart under the hood then is the next layer of machine learning, which are the general techniques or a variety of techniques that are used to make that device smart. And then there's a further subset of algorithms or techniques called deep learning. Artificial intelligence is going to be used in everything. So I'll give you two examples. If a car has intelligence built in, if it can see the world, so looking at what's on the road, looking at you as the driver, and being able to anticipate and course correct when something goes wrong, something jumps into the road. Autonomous vehicles of any kind are not going to be autonomous without artificial intelligence. In the medical field, new treatments that'll come from the analysis of reams of data to detect cancers and diseases. Today, machines are smart, and they're smart because of AI. But AI still has a dependency on us, people. We're making it possible. The next phase is when artificial intelligence is able to walk on its own. Companies like Qualcomm, if we do our jobs right, and if artificial intelligence is done right, the actual implementation is totally transparent to a consumer. But what they end up with is devices in their world that are more than utilities. They're actually experiential, and they will make your life easier.
Okay. One other very important application, as I mentioned before, is autonomous car. Current modern car, we haven't reached to autonomous level yet, but using current technology, still more than 100 computing devices are present in today's modern automotive. They are used for different type of processing, from advanced driver assistance system for automatic parking, collision avoidance, blind spot detection, to other the critical component of the car, like engine control or safety critical aspect, airbag control, and so on. Also, there are lots of computing devices are used for the entertainment system of the car, for audio system, TV, and even controlling the light and so on. So even although we haven't reached the autonomous car yet, but still today's modern car, they have more than 100 computing devices. So the demand from automotive manufacturer to have more computer engineer will be rising in next decade. So that indicates another area of contribution by computer system engineers. Okay, well, we talk about, anyway, advanced driver assistance system and autonomous car. So this short video indicates...
You've probably read something about autonomous vehicles in the news, but what are they and how do they work? Well, they use sensors, lasers and cameras to navigate the roads, and there are actually 5 different levels of automation. Today, your car is at level 1 with features like cruise control and parking sensors. But by level 5, the car can drive itself completely. All you do is tell it where to go. But what does that actually mean? Well, with computers at the wheel, you'll get from A to B faster with less congestion and less pollution. Once you arrive, your car will even park itself. But their biggest benefit is safety. Every year, more than 1 million people are killed in car accidents worldwide, and 90% of them are caused by human error. Sometimes we get tired, we lose concentration, and every now and then just get it wrong. Could driverless cars be safer? We'll have to be able to make quick decisions in all kinds of situations and share the roads with conventional vehicles, pedestrians, and cyclists. There's still a lot of work to be done, but driverless cars could dramatically cut the number of accidents on the roads and save millions of lives. That doesn't make letting go of the wheel any easier, though. There are still lots of unanswered questions. Who's to blame if there's an accident? Can autonomous vehicles be hacked? And what if you're someone who just likes driving? To find out more about what an autonomous future might mean for you, visit FIA.com.
Okay, what you have noticed here, security is also become very important when we have autonomous car, because we don't want the car to be hacked and create dangerous situation. So the following video indicate an example which having been a Chrysler Jeep car which has been hacked in 2014. This is a shortened video. Longer version is available on YouTube if you are interested more. But that clearly indicates that security is one of the most important design criteria that should be met by the computer system designer. And we see how even
it's not fun to have your 2-ton SUV's brakes hacked just as you're parking in front of a ditch.
Okay, hold on tight. Hold on.
That's what I've learned from Charlie Miller and Chris Valasek, a pair of hackers who have spent the last year developing a piece of software that can wirelessly sabotage this 2014 Jeep Cherokee.
It hasn't been altered in any way. There are no devices attached to it. But like many thousands of Jeeps around the world, it can be remotely hacked over the internet through a cellular connection to its entertainment system that would allow someone to take over its steering, its transmission, and even its brakes.
To demonstrate that, I'm going to act as today's crash test dummy and drive it on the highway here in St. Louis, while Charlie and Chris hijacked its digital systems from Charlie's house miles away. They wouldn't tell me what they had planned, but they assured me that it wouldn't be anything life-threatening.
Remember, Andy, no matter what happens, don't panic.
Right. So first we're going to turn the fan on him.
Yeah, let's turn the fan on, see if he even notices.
All right, something just turned on, all the fans and AC and stuff. I didn't do that.
The trick started small.
Oh my God. There's a picture of Charlie and Chris in tracksuits that just appeared on the dashboard.
But as I drove down the interstate, things started getting unpleasant and very loud.
Perfect. You can't turn it down.
This was such a fun video. Steve, okay, go to enjoy it.
And now the air conditioning is blasting, the music is blasting, and I can't see anything because of the windshield wiper fluid.
Okay, do it. Do it. Kill the engine.
So we're killing the engine right now.
It says park sense. Actually can't accelerate.
I stomped on the gas, but the Jeep slowed to a crawl.
It says 43 miles an hour, but I'm not going.
So in this way, they could take control of the steering wheel, the braking system, as you notice, and anyway, lots of security vulnerability exists. So this is another type of problem that should be tackled by computer system engineers. Okay, now we see how we train computer system engineer for these type of problems. The core material covered in this program has 2 major components: software design and hardware design. In software design, a student will learn using some high-level programming language, for example, this language named here. A student learn all of this plus anything additional to this depending on a specific application. To design the optimized software for target application. Optimization means performance or the speed of the processing, means energy efficiency, reliability, security as well. So all of those factors would be considered as design criteria to be met during the software design. The other important component is hardware design. So in hardware design, the student learn to design analog and digital electronics, and also learn hardware description language to design reconfigurable hardware. Reconfigurable hardware means that when you start using the hardware, that on the fly can be reconfigured to do something differently. Again, that would be useful, say, for example, when you have artificial intelligence system implemented, or some solution to adaptively change the system to tackle the security problem. Again, that could be resolved by using reconfigurable hardware, and a student will learn how to design such hardware. And when a student introduce this concept, we have different courses, project-based courses, which consider different type of application: robotic system design, distributed embedded system for safety critical and secure systems related, hardware software design for system related, artificial intelligence, machine learning, industrial automation system, and computer network. One key factor which is unique to computer system engineering program is notion of hardware software co-design. Hardware software co-design means that when we are designing our intelligent computer system, we consider both hardware and software aspect of the system in order to meet the design constraint and specified requirement. So that means in extreme cases, we may have 100% pure software solution or 100% pure hardware solution for our problem, but in practice, a mix of that, because that needs to be optimized considering the cost, performance, and other optimization factors which are relevant to the given problem. So all of this would be included in the courses that are covered by computer system engineering degree. Okay, the other thing to see how this is related to other degrees offered by our department, EC department. CSE, Computer System Engineering, is very flexible program. It has a lot of overlap with software engineering from some of the shared or common courses. It also has some overlap with electrical and electronic engineering. A student also in their final year project, they can even explore other opportunities through their final year research design project, again to explore more overlap subject between other degrees. So the labs provided for our CSE students, so these are some pictures from a specific lab or a specialized lab for computer system engineers. We have industrial automation lab when a student learn how to design such system. We have embedded system lab, which is used for hardware and software design of embedded computing devices. We also have robotics lab, which a student learn how to design, assemble, and program different robots. Again, hardware and software component. This is an example of a robot which I think used in healthcare system for elderly people. These are specific labs. There are other labs which are common or shared with other degrees. They are also available to computer system engineering. Then these labs currently are located in our New Market campus, but from 2020, so if you start anyway, if a student start next year engineering program, they will be located in new building, which as you might have noticed next to this one, there is construction activities. So we are expected to move to that building in 2020. So all of these labs, which will be better equipped, will be located in the new building. So we will have these labs plus additional extension depending on what is needed. Looking at from employment opportunities, our computer system engineers have been employed by many companies, locally or internationally. So these are some big or major companies that employed our graduates coming from IBM, Fisher & Paykel, Microsoft, and so on. Even some of my students, they've been working with me as a project, for their project. I know they've been employed in some of these companies. So there are lots of opportunities available from job market point of view for computer system engineer. So if we want to summarize what we expect computer system engineers to do, they use their hardware and software design knowledge and skills to solve the problem related to self-driving car, robots, medical devices, and other type of application. And the number of target application is increasing over time as new needs will emerge. This is one example. This is a video about 2 minutes, I think 20 seconds approximately. That indicates that how a robot plays chess. This is located in our embedded system lab. As you see, that's the picture of the lab. And this robot can play with itself as well as with human. And as you see, it was programmed by one of our computer system engineering students and we trained this game. The name of the robot is Baxter. Where to place the next move. It uses camera and does image processing, as you see here. Again, one example that our student can do in their final year of the CSE program. Okay, going. Okay, you can find more information about all of the things that I discussed here by attending the final year research project exhibition day, which will be in our New Market campus on Friday, 14 September in the afternoon. You will see different type of project which has been done by students, and you can even interact with a student if you need to get more information from them. I think the brochures related to this are available outside, so you can collect them from my colleague, and you also see some demos which are related to what we discussed here. For further information, you can check our website or engineering website, contact people in the Faculty of Engineering, or directly contacting me. We will be happy to give you more information. Also, I would like to acknowledge my colleagues who are also involved in our program. Thank you for your attention. If you have any question, I will be happy to answer now or anyway after the session. Yes?
If we're willing to go into a career for artificial intelligence,
Yes?
do you think this one would be better or computer science than the science type?
Okay. One difference between computer science and engineering is that the focus in computer science is more on theoretical aspect of computation. In computer engineering is more from the engineering and design aspect of that. But still we have some fundamental theoretical material which is needed to be learned by computer engineering. For example, assume that you have two algorithms, you design two algorithms, and before you do the implementation of those algorithms, because the implementation takes a lot of time, you want to know algorithm 1 is better or algorithm 2 is better, for example, from a speed point of view, right? Then you use some mathematical formulation to get some estimation about, say, okay, the complexity of algorithm A is higher, for example, so we expect to be slower. So those parts would be covered in computer engineering as well. But computer science, they may have more additional theoretical related material related to this. If you look at artificial intelligence point of view, if you are designing the algorithm, okay, again, it's covered in computer engineering, so that's one part. But the implementation part, especially the hardware part and software part, that is covered by computer engineering, especially hardware. Hardware is the only, the major thing which distinguishes from even software engineering or computer science. Hardware even becoming more important, even for some other cases that would have been solved a few years ago by software. For example, security. Software cannot deal with security. You need to have a specialized hardware for that. Or you might have heard, I don't know if how many of you are familiar with some of security problem with Intel processor recently. Okay, if you want even to develop software patch to fix the problem, you need to know about the processor architecture. Okay, this is covered, we have a course, and actually I teach that course myself when it was covered in our third year computer engineering course. Right? There are lots of aspects which are related to the design and problem solving skills more covered in engineering program. But still computer science has its own anyway, valuable subject. So we don't want here to say something is better or the other. All engineering programs, science, they are good. They have their own value. That's why we have all different programs. But depending on which aspect you are looking for your solution, okay, one might be preferred compared to others. Okay, any other questions? Yes?
What's the difference between the robotics done in computer systems and the ones and robotics that's done in mechanical and electronics?
Okay, robots, it has mechanical part and the computational part, right? Like human, okay, we have the brain which does the processing and the moving of hands, legs, anyway, the mechanical part. The mechanical part is managed by mechanical engineer and mechatronics. The computational part, some part of that to some limited level is considered by mechatronics. More detailed aspect of that is considered or will be dealt by computer engineer. But this doesn't mean some mechatronics engineer, they may take some additional courses, even elective from computer system to cover more computational part, or computer system engineer takes some courses, especially related to sensor processing, measurement, other things from mechatronics. So there are some overlap, but in computer system, the emphasis is on more hardware, software co-design for all different type of application. But if you are targeting a specific application like robotics, there are some overlap between these two degrees. Okay, so computer system is broader from intelligent computing device design point of view. Okay, other questions? Okay, thank you for your attention. I will be available if you have more questions. Thank you.